Okay, so now what we do is we don't use gradient descent directly like on the whole data set because the data set is too big. And as you know that you need like a lot of images, like millions of images to train your model. So if you try to compute like the gradient or the loss function for the whole data, it will be very, very time consuming. Right, so what we do is we use like a variation of that, which is called stochastic gradient descent. And the idea is you select like a few samples from the data set and you compute loss for those fewer samples. So that's called a mini batch, or you can say a batch. And then you perform this training. Okay, so we randomly sample like a data point. So again, this is stochastic. We just do for 1 point, but ideally we don't do for 1 point. We take like a bunch of points, which is again called not stochastic. You can say that mini batch gradient descent. All right. So, and that is also called the batch size. That's like the amount of the number of samples you're actually using to train your model. And this is one of the hyperparameter. And it actually plays a very important role, like how good your training will be. So like a very big batch size will improve your training speed, but it might not be very good for the performance. And again, if you have a very small batch size, let's say as small as 1, because you are making those updates for each sample, it's going to take a lot of time. Okay, so the idea is, so this is like a very simple training process, how it works. You first of all initialize like all the network weights randomly, and you will have some kind of learn rate. Again, it's a hyperparameter, you will choose it. And then while your loss is not like the minimum one, you will continue your training. Okay, so that's, let's say, your stopping criteria. You can have other stopping criteria as well. For example, you said, okay, we'll train the network for these many iterations, or you can say like we'll train for these many days or these many hours. You can have lot of different variations there. So you will have some criterion to stop. Then what you will do is you will randomly shuffle your training set. Let's say you have 100,000 images. That will be a long list. You will randomly shuffle that list, and then you will start from the top. And let's say your batch size is 16. You will select like the top 16 images, and then you will feed forward those 16 images through your network. For each image, you will have some prediction. You will have the ground truth. You can compute the loss. So you will do that for all the 16 images, and you will just average that loss, right? So that's the loss for that particular mini batch, and you will use that loss value to find the gradient for all the parameters or all the weights in the network and update the weights. Okay, so if you think about this, what's happening is you are improving or you are learning your weights depending on only these 16 samples. And so that's called one iteration because you're training your network once. Okay, so that's called like a single step of gradient descent, and you repeat that for all the samples. You will keep sampling next 16 images, next 16 images until you have used all the images in the training set. Okay, so once you're done with all the images, that's called one epoch. Okay, so that's again a term you should know. So one epoch is something when your network has actually seen all the samples in your training set. All right, and then again you repeat. You will shuffle again those images and keep repeating this process. And usually you train for like multiple epochs. And you will, as you are training those on those images again and again, your network will make better predictions because those weights are actually going towards the minimum. Okay, so that's like a high level idea of how the network training works. So this is called like one epoch when, as I said, your network has seen all the images in your training set.